Now let's move to the question number 11. A cylinder has the radius r and the height h. The total surface area included the two ends is a centimeter square. The volume of the cylinder is 330 centimeter cube. Show that area is equal to 2 pi r square plus 660 over r. Surface area of the cylinder, for example, this is a cylinder which has two ends of the circle. So you can say that surface area of this cylinder is equal to two ends surface plus a curved surface. Two end surface is equals to 2 time of end surface is the area of the circle, so it is 2 pi r square plus curve surface is equals to 2 pi multiplied by height. If this one is height from here to here and this one is the radius, so the curved surface will have the area of 2 pi r h. So total surface area is 2 pi r square plus 2 pi r h, and volume of the cylinder is equals to the pi r square h. This volume is given, so we can find the value of height. We can say that first volume is given, which is 330 centimeter cube. Plugging this formula, we will have pi r h. Pi r square h is equals to 330. So in this case, h is equals to 330 over pi r square. Okay. We need to find the area of the total surface area of the cylinder. So total surface area, I just told you, is two end surface and a curved surface. So which is 2 pi r square and 2 pi rh. Further solving, we will have 2 pi r square plus 2 pi r, and h we just calculated, which is 330 over pi r square. So r will be cancelled out and pi will be cancelled out. So we will have 2 pi r square plus 2 times 330, which is 660 over r. So this one is the area. Part B, given that r can vary, find the value of r that gives the stationary point for A and show that this value is minimum. We already have the area, which is equals to 2 pi r square plus 660 over r. Okay, we need to find a stationary point for the area. So it's mean we need to find the derivative of the area with respect to r. And using this derivative and equated it with 0, we will get or find the value of r. So we need to find the derivative of the area. So dA with respect to r is equals to derivative of 2 pi r square plus 660 over r with respect to r. 2 pi is constant and derivative of r square is 2r plus 660. Derivative of 1 over r means derivative of r inverse with respect to r. Further solving, we will have 4 pi r plus 660. Derivative of r to the power of negative 1 is negative 1 time r to the power of negative 1 minus 1. So we have dA over dr is equals to 4 pi r minus 660 r to the power of negative 2. We need to use this derivative and equate it with 0 to find the value of r. So it will be 4 pi r minus 660, and r to the power of negative 2 is written as r square in denominator, which is equal to 0. So further solving, we will have 4 pi r is equal to 660 over r square and r cube is equals to 660 over 4 pi. So r is equals to cube root of 660 over 4 pi. Now we need to show that this stationary point is minimum. To find the nature of the stationary point, we need second derivative of the area with respect to r. So we need to derivate this equation again, this one. So derivative of, so we need to derivate the first derivative, which is already 4 pi r minus 660 r to the power of negative 2 with respect to dr. Derivative of 4 pi r is 4 pi minus 660. Derivative of r to the power of negative 2 is negative 2, and r to the power of negative 2 minus 1. This one is equals to the 4 pi minus 1320 r to the power of negative 3, and this one should be positive. So okay, so we have second derivative of the area with respect to r is equals to 4 pi plus 1320 over r cube. Now we need to find the nature of the stationary point, so we will plug r of the stationary point in the second derivative to find whether it is positive or negative. So r square e over r square r, when r is equal to cube root of 660 over 4 pi. So this one is equal to 4 pi plus 1320 over r cube, means this one. So cube root will be cancelled out and we will have 660 over 4 pi. So we will have 4 pi plus 1320 times 4 pi over 660. So this one will be 2. So we will have 4 pi plus 8 pi, and this one is equal to 12 pi. This one is positive. So we can say that second derivative at stationary point is positive. It means the stationary point is minimum. So because it is greater than 0, so stationary point is minimum.